In this video I'm going to explain to you how to plot or visualize the results with the help of program Graphic. I have already used several times in my representation the results received in Graphic, and I always refer to these results like I'm going to explain it later in the course. So now we reach the point where I'm going to explain how this is working. We are going to start graphics externally by clicking on this button. But first I would like to mention that the previous name of graphic was Wingraf, and sometimes I still might use Wingraf. The reason why its name has changed is that we wanted to refer to the functionality of this program for the new users when it is necessary to plot either the input or the output of the database. So after having clicked on the graphic button, the following user interface can be seen. As a general information at the beginning, I would like to add that it could be that I'm going to also represent the input or the output of other databases, simply because it contains quad elements, for example, and I can represent some of the results much better with the help of those type of finite elements. First things first, let's start with the toolbars to be activated. Or I should reformulate, let's choose the toolbars that I would like to suggest you using. If you right-click on any of the icons in the topmost toolbar, you are going to see the available toolbars to be open, and also you can see the already activated toolbars by me. What I can suggest to be open is definitely the setup toolbar that we are going to use extensively. If it is active, then you should see these two icons on this setup toolbar. Also, I recommend to activate all the toolbars with the ending info, such as the finite element info toolbar, further element info toolbar, and also the structural element info toolbar. The structural element info toolbar can be seen here, then it follows by the finite element info toolbar, and the further element info toolbar can be seen here. For example, if you want to receive some information for edge elements or beam tendon information, then you can use this toolbar. Another very important and useful toolbar is this one, which is called New Graphic Picture Layer Copied from Current. This is also a toolbar that we are going to use frequently. One can move back and forth a toolbar, so maybe it's sometimes useful to move it and drag it to another position if you want to. And by the next reopening of Wingraf, the position of the toolbar will be kept. Another important basic setting is the command line position and size, which can be also controlled by the users if you simply select and drag the upper frame of this command line. Normally I'm using 3 or 4 command lines to be able to receive some feedback from graphics or Wingraf, what should be the next move or the next step, and sometimes also values are presented in this command line. This information concludes this video about the toolbars of Wingraf. In this video I would like to show you how to select different type of elements and represent them in Animator. Let's suppose that after having run a design check, for example, on your system, you receive some warning messages or error messages referring to a beam element with its number. Of course, the next step would be to search for this beam element to allocate the problem and see where this beam element is situated in the system. In Wingraf you have lots of possibilities to search for an element according to its type, for example. The structural element info toolbar allows you to search the system for structural elements, such as structural points, structural lines. If your system contains structural areas, then according to structural area or according to structural volumes. It is also possible to search according to finite elements with the help of the finite element info toolbar, on which you will find some buttons that enable you to search for according to finite element nodes, quad elements, beam elements. If we had truss elements in our system, we would be able to search for truss elements, cable elements, spring elements. They are already existing in our system, therefore it is active to search. Then if we had boundary elements, we would be able to search for them. The third option to search according to type of element in the system is with the help of the further element info toolbar, on which you can search for kinematic couplings, or if we had volume elements in the system, that we would be able to search for the brick elements in the system. We can search for edges in the system, or circuits in the system, design elements in our system, quad tendons, or beam tendons. So as you can see, there are a lot of possibilities in Wingraf to search for an element. So all you need to know is what type of element you are searching for and enter its number. Let me show you. Let us suppose that I'm searching for a beam element, so I will click on the finite element beam info, and in the command line you will see the available beam element number in the system starting from 100,001 until 200,068. And in a very special type of bracket you will see the starting number that Wingraf is offering for the first representation. If I now hit the enter button, then the suggested element will be shown or highlighted. But of course it is also possible to enter a beam element number. For example, if I enter 200,035, which we already knew where should be located, we will really see that the element that we were expecting is highlighted. I will also enter 200,017 to see it in the midspan. And if I now hit the enter button, Wingraf will automatically zoom into this element, like this. And by default, it offers me the next element for selection. With the escape button, you can terminate the command, and by clicking on the zoom extents or zoom word button, the structure will be presented with its extent. Now let's assume that you have a quite complex model with a lot of structural elements in it. Try to imagine an office building with lots of floors, walls, columns and beams. And in this case, sometimes searching for an element could be quite challenging. Now I would like to show you a workflow which could be very useful in these complex structures. First, I need to introduce to you some new commands. For example, on this toolbar you can see the global coordinate system plane YX, ZX and YZ. If I click on the YX system, my structure will be presented from the top view. If I click on the ZX button, my structure will be presented from the side view. A small symbol of the global coordinate system can be seen on the page to help you oriented. If I now go back and click on the YZ button, then my system will be presented in the YZ coordinate system. And the last one is a three-dimensional system view, which was presented previously by default. The other two important commands that I would like to represent is the so-called box and the structure limits. With the help of command box, basically you can cut out a part of the structure with a box. And if I now click on the structure limits, then my whole structure will be presented once more. Now let us click on the top view, the XY view, and try to imagine the before mentioned very complex structure of ours. The workflow I wanted to show to you is as follows. Let's search for a spring element, so I will click on the spring info button and type in, for example, 200,106 and hit the enter button. So what I can see is the spring element is located somewhere here. So I will use my box command and I will draw a box around this area. And now I will switch the view by clicking on the ZX system view. Again, I'm going to search for the very same spring element, 200,106, and hit enter. Now I have a better view about the selected element, but I'm still going to draw another box around this element and narrow down my location. Now I will switch the view to the YZ plane and again search for the spring element by clicking on the spring element info and entering 200,106 and hit the enter button. Again, I'm going to use the box command to narrow down the view of my structure. And finally, I'm going to represent my structure in the three-dimensional view by clicking on this icon here. And using this procedure, I can have a very nice overview where the selected element is located, especially when we try to imagine a very complex system. This view then can be overtaken to Animator or the system representation in SSD. So if we go back to SSD and select the system visualization ribbon to be presented, on this ribbon you are going to find an icon stating settings from Graphic. And if you click on it, the settings that had been generated in Wingraf or Graphic will be overtaken. So you finally found the right spot of your huge and complex structure. And now if you click again on the settings from Graphic button, then the overall structure will be represented again. Maybe now it is useful to click on the cross sections representation and choose the no cross section visualization in order to see the beam elements, the tendons, and the spring itself. In our simple system, it's not a big deal to find any of the elements, but I hope you can understand and you can imagine how useful this workflow could be when you are facing with a very complex model with lots of beam elements, quad elements, columns, springs, kinematic constraints, and so on and so forth. Okay, this information concludes this video, and I'm going to continue the introduction of Wingraf by explaining the most important commands and representation types in Wingraf. In this video, I would like to show you the most important functions for representation and selection in Wingraf. Let's go back to Wingraf now and show the extent of the structure once more by clicking on the Structure Limits button here. And in this video, I would like to go through first on this left sidebar. Wingraf is capable of representing the content of the CDB. So if something is stored in the CDB, that you can be sure that it can be visualized in some way with the help of program Wingraf. The reason why I'm telling this information or sharing this information is that not just the results can be seen in Wingraf, but also the input. And this makes Wingraf a very powerful tool for reviewing the model or double-checking the model. On the left sidebar, we will find the first tab, which is called Structure Values Loads Result. Below this tab, we can find some entries such as system values, loads, results, design. Please notice that the order of these entries tries to follow the input of your modeling. First, we defined the system values in SOFiSTiK+, such as the structural elements. Then, after having meshed the system, we received finite element nodes, beam elements, spring elements, and kinematic constraints. Then we defined the loads in the system. Then we run a linear analysis, and then the results were available for us. Finally, we undertook the design of the beam elements. Now let's try to represent some of the system values. For example, if you open up the structural elements entry and choose the structural lines entry, you will find the structural line that we had defined together in SOFiSTiK+. Although the numbers are a little bit small, but we can help about that by sliding the slider a little bit to the right, and now the numbers on the structural lines are much bigger. So in this way we can represent the system values, for example structural elements, or we can have an overview about the number of the beam elements by selecting the beam elements and the number of element. We can make the numbers a little bit smaller, or even we can rotate it by clicking on the cross text button, and then the number of the beam elements will be perpendicular to the beam. In a very similar fashion, we can have a look at on the loads. You will find three main chapters there: the input loads, which represents the load as you defined in SOFiSTiK+. Then in the used loads chapter, the loads will be represented as the program understood this loading and applied to the necessary elements, will be converted to finite element nodal loads. In the meantime, I received a message from Wingraf that whether or not I would like to save this Wingraf file. I will choose yes. But before I do so, please notice where this Wingraf file will be stored and with what type of extension. So it is going to be stored in the project folder. However, the extension will be the project name.gra, since it is a graphic file. So I will just simply click on the yes button, and now it is saved. Also, it is worth mentioning that in this first info line, you can see the graphic file that is opened, and also the database that it's representing at the moment, because it is also possible to represent a different database within this GRA file. But now let's go back to the left sidebar. So after having defined the loads within SOFiSTiK+, then we run the linear analysis, and then results were available for us. These results can be reviewed in the results chapter or results entry. If I open it up and, for example, open the beam elements entry and choose the forces and the bending moment My, and select one of the loadings, for example, curvature loading number 11, and click on the yes button, the My bending moment of the load case 11 will be presented on the screen. Of course, different type of representations are available in Wingraf, which I'm going to cover later on. For now, I just want to emphasize that basically what we are looking at or what we are reviewing is the results that has been stored by module ASE or module CSM in the database. And if we remember, after the linear analysis, we undertook the design. So if I now go ahead and choose the design chapter or entry and choose the beam elements and select the design, for example, and here I will select the longitudinal reinforcement in layer number 1 from design case number 1 and click on the OK button. Then the necessary amount of reinforcement in layer number 1 from design case number 1 will be presented on the screen. But of course it is possible to represent other design results, such as, for example, the stress of the material. If we select this entry and select, for example, the maximum compression stress, then we just need to select a design case. For example, 2105, I believe, is for the ULS Design Max MY case, and then click on the yes. And now, for example, we can see the maximum compression stress in the pier. Similarly, it is also possible to represent the stress of the stress point within the cross-section, or the stress of the shear cut, the stress of the tendon, and then the utilization level of the cross-sections. Finally, as the last entry, we are going to find the deformed structure representation opportunity. And here we can choose to select the nodal displacements. And since I was representing load case 11, which was the curvature load, I received a warning that load case 11 is invalid for representation of the nodal displacements. So the load case will be automatically changed to the first valid one, which is 31. I will click on the yes to accept this. And now I just need to set up a factor. For example, instead of 10,000, I will just simply add 1000 and click on the OK button. And now I will see the deformed shape of the structure, or the nodal displacement of the structure. Load case 31 was the wind loading, so when we see a deformed shape in the global Y direction, it seems to be reasonable. As a personal preference, I do not like this type of representation, so I'm always representing all of the results on the no deformed structure opportunity. So I will double click on this no deformed structure and then click on the OK button. And now the original structure will be presented on the screen. For further explanations, I'm going to go back to the results entry, beam elements, forces, and choosing the bending moment MY diagram. And as you can see from load case 31, there is no MY bending moment occurred, which is reasonable. So if we would like to represent or show another load case, then all we need to do is click on the second tab, which stands for the load or design cases. If I click on it, the currently shown load case is highlighted, number 31. So for example, let's choose now load case 51. And now the MY bending moment of load case 51 is shown on the screen. You can move back and forth within the load cases if you click on the LF- or LF+ buttons, select next load case or select previous load case. So if I click on the select next load case, you can see that I'm scrolling through the load cases. If I click on the LF-, I'm scrolling back the load cases. Now I would like to talk about the group and the group all buttons, which can be found very next to the box button, which we already discussed. If I click on the define groups button, then a new dialog box will appear. And here you can select or deselect some of the groups or their elements in the representation window. For example, if I now deselect the constraints and click OK, you can see that the constraints disappeared at the middle support or at the end or at the beginning of the structure. If I now click on the Group All button, then all groups of the system will be presented again. I will click once more on the Group button, just to show you that here multi-selection is also possible. For example, if I use the Control and my left mouse button, I'm able to select, for example, 2 cells. and then with using my right mouse button, I can choose the uncheck selected and click on the OK. Now all of the spring elements are disappeared, or at least not presented in the system. Again, if I click on the group all of the groups will be presented. I will go back once more to the Define Groups window, just to show you that a window selection is also possible if I start to click with my left mouse button and keep it pushed, and when I move my mouse to the right, then multiple cells will be selected. And again, if I choose the uncheck selected and click OK, now only the beam elements will remain in the system. Okay, I think you get the hang of it, so I will click on the Group All button to represent everything within my structure. In this view, it could be a little bit disturbing that also the axis and the placements are presented. So I will show you how to turn them off by going to the Edit menu and choosing the Axis submenu. And here you need to choose the Show Placements and unselect it. And now the placements are disappeared. If you also want to avoid the presentation of the axis, then you need to go back to the Edit menu and the Axis submenu and go for the Show Axis submenu and then deselect the central lane of the bridge. I think this is a much clearer representation of the whole structure. Next to the Group All and Group buttons, you can find this Change Box button. When you have a boxed view defined already, then you can set the properties of this view box with this button. Let me show you. So for example, if I click on the box and create a box view, now I can click on this box or change box button and I will be directed into this dialog box in which we can see all the information regarding this preview, and if you want, you can set any properties of this view. However, we are not going to do that. I just wanted to show you that it is possible, so I will simply click on the Cancel button and continue with the explanation by showing the functionality of mirroring with the help of these two buttons, mirroring vertical or mirroring horizontal. But first, make the structure visible again with its all extents by clicking on this Structure Limits button. And now I can represent the vertical rotation or vertical mirroring. If I click on it, the structure will be mirrored and along a vertical axis. And if I click on the horizontal reflect or mirroring about a horizontal axis, then you can see the structure upside down. It is also possible to rotate the structure view with 90 degrees. And if you are still not satisfied with the view, then you simply need to use this 3D button, which will drive you to the Animator or the system visualization. And with the help of this little tool, you can rotate your structure in the desired position. Also, you can drag your structure with your middle mouse button, and then when you click on the OK button, the structure will be represented in the previously set view. The next button will be also open up the Animator or the system representation, but in a separate new window as a standalone program. So this means that from Wingraf it is possible to open Animator or the system visualization. Also possible to open the report browser or the result viewer. We can try these options out. So if I click on the Animator symbol, then as you can see in a separate new window, the system visualization or Animator was opened and the selected load case 51 is being presented. If I go back now to Wingraf and click on the Teddy icon, then the Teddy will be open for me and the current view will be represented in CADIMP input. For now, just simply close BackTeddy and go back to Wingraf without saving this. And then we can also call up for the result viewer by clicking on it, and then the result viewer will be open with the first found cross-section. So as you can see, there is a possibility from Wingraf to open the different type of programs from SOFiSTiK at any time you need for them. Then you can also find a normal undo and redo button like in any other Windows application. The forthcoming 3 buttons I would like to explain a little bit later. Previously you saw me sliding the slider, and then the size of the text changed. So basically with the help of this slider, the text size can be controlled. Also, there is the possibility to represent the text crosswise. So when a text is presented horizontally, then now it's going to be presented vertically and vice versa. The next button is responsible for representing the extreme values. If you uncheck it, then every value will be simply presented. If you select it, then the extreme values of the diagram will be rectangled. Then with the help of the next button, you can control the representation of these extreme values. So for example, by default, you will see an empty rectangle around the extreme values. Then if you click many times, you can cycle through the options, such as showing the min and max text in front of the extreme values. Or if we further clicking, these values will be grayed. And with the next click, the min-max will disappear, but they will be still presented with gray background. And finally, we get back to the original representation type. Let me mention at this point that it is also possible to change the magnitude of the diagram. Let me show you how you can do that. There is another slider in the toolbar which has a small unit definition button on the right side. And if you start to move the slider to the right, for example, then the magnitude of the diagram will be enhanced. So with the help of the text size slider and with the help of the diagram magnitude slider, you can reach any type of representation according to your taste. The next toolbar I would like to talk about is the decimal toolbar, on which you can set the number of the decimal places. For example, if I click on the 0, there will be no decimal places represented in the view. If I select 1 decimal places to be represented, then as you can see, the text change, and really we can only find 1 decimal after the point. Or simply you can choose the engineering form, but the default is this .d, which means depending on the value, which follows an underlying rule for the best representation on the screen. After having gone through all the most important buttons in the toolbar, I would like to talk a little bit more about the third tab, which is about the representation. The representation can be selected. In this simple system, we only have the possibility to choose the text representation without any diagram, or we can select the line representation as we saw before, or we can also request for a list. However, let me open another model file and the corresponding Wingraf file to demonstrate all the other representation types. So now I have opened another file that represents a simple 2D system. Then you will see the default representation of these bending moments. This is, for example, the vector representation, but if I select the isoline representation, it is something that most of the cases we would like to see when we are presenting results of quad elements. But it's also possible to choose, for example, the ISO area representation, which is a very nice colorful picture. However, please notice that the original list and text representation is still available for us. Okay, so what you need to remember is that the representation type can be selected on the third tab of the left sidebar. Now let us go back to our original example file and continue by clicking on the first tab, because I would like to show you what other ways there are for choosing a nice representation type. If you double click on any entry, you will find yourself at the Results Definitions dialog box. Within this dialog box, of course, you will find again new tabs, which allows you a better representation of the results. On the first General tab, you can select what you would like to represent on the screen, the system or the loads or the results or the design, which are corresponding to the entries that can be seen in the sidebar. Also, you can select the load case within this General tab. And you can also choose the representation type from this drop-down list, such as text, line representation, list, and so on. And you can also choose the representation type, such as line representation, text, or list. This Result Definitions dialog box is the tool with which you can set anything, really anything that you would like to. And of course, what it is possible with Wingraf. What I mean is that most of the commands can be reached outside or from outside with the help of icons and commands. However, if you want a really in-detailed representation or go into the details, for example, changing the text style or the text width, for example, then you can only achieve your goal with the help of this Result Definition dialog box. Another important information to mention here is that this Result Definition dialog box and its corresponding system, loads, results, or design chapters can be also reached from outside. So for example, if I click on this icon here, I will find myself and at the General tab at the System radio button. If I click on this Loads button, then I will find myself in the Results Definition General tab, Loads radio button selected. And as you can see, since the Results is selected, now here the Results toolbar or the Result button is already on. And the fourth one, the Design button, will direct you to the General tab and the Design radio button selected. Now I will simply click on the OK button and leave the dialog box. This information concludes this video, and in the next one I'm going to show to you how to add text and lines to the view. In this video, I like to show to you how to add additional text or lines into the view. With the help of this additional text and lines toolbar, you have the possibility to add additional text, lines, dimension lines, or raster. These commands are also available through the Edit menu. So if I open up the Edit menu, you will see that it's possible to define these lines, text, positioning symbols, level symbols, dimension lines. I'm not going to go into detail for all of the additional text lines and dimension lines. I'm just going to show you some of them because the basic principle is valid for all of these commands. To demonstrate this, I have chosen the XZ plane, and I would like to insert, for example, a single dimension line. So I will click on this command, and then in the command line, the software let me know what the next step should be, namely to choose a first point for the dimension line. So I will do that. However, for some reason, I have activated the object snap, so I will just choose from the drop-down list the no object snap, and then click at the middle support point once, and then at the beginning of the first pan, and then right away again in the command line the red value can be seen. If I accept it, I just need to hit the enter button, and then the value will be presented in the view. If I want the text make a little bit bigger, I just need to grab one of the corner points and make it bigger, and then hit the enter once more. Please notice that I'm still in the definition of new dimension lines. So, for example, I can make another one by choosing another point and then another one as well, accepting the value and accepting the text size, since now the text size will be exactly the same as the previous one, and I simply hit the enter button. And according to the command line, I'm still in the definition of new dimension lines, so I can terminate the command if I simply hit the escape button once more. And then I receive an information that 2 new elements were defined. If you want a little bit of more precise measuring, then of course you can also activate an object snap toolbar by right-clicking on the toolbar and selecting the temporary object snap toolbar, and then it will appear. Unfortunately, the only object snap that is working at the current status of the software is the very first one, the single point object snap. So if you click on it, then the software will find the end point or the beginning point of a beam element. I try to demonstrate it by simply choosing the multiple dimension lines, and I will choose the single point object snap, and I will choose the node here, and then I have to once more choose the single point F2, and then I need to select another nodal point, and right away if I hit the enter and the enter once more, then the escape to terminate the command, what you will see is now I managed to measure the exact value of the first span with the help of this object snap. Let's try to insert a multi-line text now. You just need to click on this very first icon and click on a point and drag and then release. And then now I have the possibility to enter a text, for example, test 1, and then I will hit the enter button. And if I hit the enter button once more, then I still have the possibility to resize the text if I want to, for example, make it a little bit smaller. And now I need to hit the enter button once more and then click on the escape to terminate the command. And as you can see, this is the way how I can insert a multi-line text if I want to. In a very similar fashion, the insert text with frame command will work for you, and also the insert position symbol or insert level symbol. The style of this additional text and lines, as I mentioned, can be set in the edit menu, and by choosing, for example, the level symbol, and then here you can choose the properties for such as the text height, the angle, or you can even assign a group number to the level symbol. Of course, we do not want to do that right now, so I will just hit the escape button. However, what I would like to show is how to change or edit a text, an already created text. So I will open up the edit menu, go to the text and change text, for example, and here I will add edited text and hit the enter, and right away the content changed to the edited text. Similarly, you can change other properties of the text, such as the color or the orientation. So if I choose, for example, the change properties, and I will need to select the element by entering the Y for yes, and then I can add the exact text height, for example 0.25, comma, and then, for example, a desired angle of the text, such as, for example, 5 degrees, and then hit the enter. And as you can see, the text shrinked a little bit and rotated 5 degrees. Finally, I would like to show you how to delete a text or an object, a text or a line object. You need to open the edit menu, go to the text, and here you have the possibility to delete texts. And if you want to select the already highlighted text, you need to simply enter the letter Y for yes. If you do not want to select, you simply need to enter N for no. Now I would like to delete it, and I'm getting a warning from Wingraf. This is really what I would like to do, and if I say yes, then the text will be deleted. Maybe it is also worth showing to you that if I select the perspective view now, the dimension lines that I have entered keeps its original value, since I have defined them in the XZ or YZ or XY plane. So what I would like to say is that always define the dimension lines in any of the planes, but not in the three-dimensional system view. Because if you define one dimension line in the three-dimensional system view, it might not be keep the original value when you change this 3D perspective. Okay, that concludes this video about the additional text and lines, and I'm going to continue the explanation of Wingraf in the next one. In this video, I would like to show you how to define a cut in Wingraf in order to represent the results of the quad elements. Therefore, I have switched back to the model that I previously showed to you, and I will select some internal forces for representation. So I will go to the results entry and choose the quadrilateral elements, forces, and, for example, bending moment mxx in the local x direction. I will also select the third tab, the representation type. The reason why I'm doing this, because when we define the cuts, new entries will be available here in the representation tab. To define a cut, you need to use this button in the toolbar, and to create a cut, either you need to use this button here or go to the edit menu and select the cuts. This is what I'm going to do, because first I would like to add a group number to the cut. So I will select this submenu, and in the command line I will simply enter group 31, for example, and hit the enter button. Now I can be sure that all the newly created cuts will be assigned to group 31. I will go to the top toolbar and select the create cut command, and as you can see from the command line, the software waits for me to define a from point. Of course, again, you can use the object snap if you want to, but this time I will simply define the cuts or create the cuts by my hand. So I will click the from point and the end point. Then I will right click with my mouse and select the return. Then please notice that we are still in the creation of the cuts. So I will create one more cut, for example, somewhere here, going into the global X direction. I try to be as horizontal. I try to create a cut as horizontal as possible. I will click with my left mouse button, then again with my right mouse button and select return. And maybe one more cut I will create here, and then I will select the return, and finally I will hit the enter button to finish the definition. And as you can read here, 3 elements were defined. Also, please notice that as soon as we have finished with the definition of the cuts, 2 new representation types has been generated within the entries, namely the cut and the list, cuts results. If I make the numbers a little bit bigger, then you can see, and automatically the values and the diagram presented in the XY view or the XY plane that we have chosen. It is very important to point out that if I go back to the structure values, loads and results tab, two new entry has been generated there as well. The bending moment in the direction of cut and the bending moment perpendicular to the cut were not present here previously. Let's select the bending moment in the direction of the cut first and go to the isometric view, and what we will find is the bending moment MXX in the direction of the cut. We can also review, of course, the bending moment perpendicular to the cut, and this is what we saw from the top view previously. Now I would like to remember you that I have defined the cuts in group 31, and the reason why I did it is because now if we go to the group or the settings of the group or group selection table, we are able to unselect the group, and in this way we are able to get rid of the representation of the cuts. Very simple. And if I now click on the group all, the results will be presented again. Finally, I would like to show you how to delete the cuts. It is possible again through the edit menu, go to the cuts and then choose the delete cuts. And now the first cut is selected. If I would like to delete it, then I need to come down to the command line and select and type in yes. Then the second cut line is being selected. If I would like to delete it, I will type in Y once more, and for the third one I will type in no and then enter. And now Wingraf gives me the warning that whether or not I really would like to delete the two selected cuts. I will say yes, and as you can see, the two selected cuts have been erased, only the third one is kept. With this information we can conclude this video, and I'm going to continue explaining the Wingraf options opportunities in the next one. In this video I would like to show to you how to use the graphics, the layers and the pictures in Wingraf. I will use the original example file of ours. We'll just get rid of the dimension lines. I have deleted all the dimension lines, and I will go back to the ZX view and I will select the fourth tab, which is called the Layers tab. In this video we are going to use extensively the icons on the Layers toolbar and also on the Setup toolbars. So basically these 5 icons will be used in this video oftentimes. First, let's investigate what we can see in the screen. According to the left sidebar, which represents at the moment the Layers tab, rather I would use the terminology we can see one A4 paper. On or in the one A4 paper we can see one picture, and within this picture we can see one layer that represents the bending moment MY of the beam elements from load case 51. So the question arises automatically, how can I define many pictures in one A4 paper, and especially how can I insert many A4 papers into Wingraf? And this is what I'm going to show you now. I will simply select the layer that is presented in this picture, and with the help of this button here the new layer will be inserted. I will simply click on it. As you can see, by default the previous layer is copied and it is presenting exactly the same content as the previous one. Therefore, it seems nothing changed on the screen. However, if I change the content of this newly created layer, for example, go back to the Load Case tab and select the settlement abutment at the end, or maybe 52, the settlement at the middle pier, now you can see how the represented view on the screen changed. At the moment I am presenting one A4 paper. In the one A4 paper I am presenting one picture, and in this picture we can see two layers. One of them is presenting the results of load case 51 and the other one is load case 52. This representation doesn't make too much sense, so I'm just simply going to delete the second layer by selecting it and click on the delete button. Or choose the delete from the drop-down list. Let me show you now what happens if you duplicate the picture instead of the layer. So I will simply select the last layer and I will click now on the duplicate picture or new picture. And what happens is a new A4 paper, a new graphics has been inserted with a new picture and with the very same layer. However, if I change the content of this newly created graphic picture and layer, so for example select the load case 52 and go back to the layers tab, now we can see the representation of load case 52 in a separate A4 paper. As you can see in the layers tab or below the layers tab, now I have two A4 papers and I can switch back and forth with the help of these buttons here between the graphics. So basically I'm scrolling the A4 papers with the help of this button. If these buttons are not presented in your Wingraf, then you need to right click on the toolbar and search for the turnover graphic, and then you can activate or deactivate this toolbar. Now let us continue by inserting a new picture into one A4 paper. This is what we can achieve if we click on this graphic setup button, and the drawing setup dialog box will be open. And on the right side below the partition chapter, we can select how many pictures we would like to incorporate in one A4 paper. We can even select according to height or according to width. Now we are going to choose that according to height I would like to see 2 pictures per page. And if I leave the dialog box with OK, the original A4 paper has been split into 2. But please notice only the selected one. The original A4 paper was not split. So if I roll out the second A4 paper, I can see one picture and one layer in it. What I need to do now is insert a new picture for the second empty part. And this is what you can do by simply clicking once more on the Insert Picture button. And then by default, with the same content, a second picture will be inserted. If I want to change the content of the second picture, I will select the second picture and the layer within it. And for example, I go back to the Load Case tab and select Load Case 51. Now, as you can see, the representation is much more interesting now, because in one A4 paper I am presenting the bending moment diagram of the beam elements in load case 52, and in the very same A4 paper I am representing the bending moment diagram from load case 51 of all of the beam elements. However, there is a slight inconvenience at the representation of the values, because the magnitude of the diagram is a bit too big, and also maybe the text height is a little bit too big. So now I will try to change this and apply the change settings to the first picture as well. The way how you can do that is to go back to the Layers tab. In the Layers tab, of course, you need to select the layer you would like to change. So here I would like to change the amplitude of the diagram a little bit, and then I do not need to even change the text size. This is going to be fine for me. And now if I select the other layer, load case 52, in the other picture and right click on it, I have the possibility to choose the replace layer properties with the Ctrl-H keyboard combination as well. And if I select it, the diagram magnitude changed here as well to match with the other picture. And if you scroll back and forth between the layers, you can see that the slider position here is not going to change. So it means that the magnitude of the two pictures is exactly the same. Let's see how you can set up a user-defined scale for the representation of the structure. For example, if I click on the setup, now I can select the user-defined scale. Instead of 230, for example, I will apply 250 and click on the OK button. As you can see in the bottom right corner, the scale changed to 1 to 250. Unfortunately, this property cannot be copied over to the other layer. You must select the other picture and the layer within it. Go back to the setup option and set the user-defined scale according to your taste, for example 250, and then click OK. Finally, let's see what's going to happen if I click on the Insert New Graphic button. Then a new graphic will be inserted, of course, with the very same content by default. However, now it is very easy to change, for example, only the load case number here to 92, for example, and 93. And now we are representing the bending moment diagram of load case 92 and 93 in one A4 paper. This information concludes this video about the definition of the graphics, pictures and layers, and I'm going to continue with the explanation of Wingraf in the next one. In this video I would like to show you how to manage a selection in Wingraf. In order to do that, I will simply select the first graphic when we only have one picture and one layer in the A4 paper. And I will use the already learned box option and select only half of the left half of my structure. This selection can be managed with the help of these three icons here. So for example, this one is the so-called Selection Manager button, this is Define New Selection, and this is Show All or Switching All Selection. I will now click on the Define New Selection, and on my other screen appeared this dialog box. With the help of this dialog box, I can save the current selection as a view. The only thing I need to do is enter a name for it. And I will simply click on the OK button. Now if I select the first graphics or the first A4 paper and I click on the new graphic insertion, then a new paper or a new A4 paper will be inserted with the exactly same content. Now let's suppose that I'm selecting the layer on this A4 paper and I will simply show the extent of the structure, show all the groups and represent something totally different on this in this layer. For example, I go back to the first tab and choose the loads and, for example, input loads, all loads, and I will select load case 31, for example, the wind loads, and I will even change the view of the structure. So now if I go back to the Layers tab, in the first graphic I have a selection with some representation on this selection, and in the second A4 paper I have something completely different. However, if I go now to the fifth tab, which is about the selections, I have the opportunity to apply the selection on this presented layer. All you need to do is to click on this selection, and now the load case 31, the wind load, is presented in the layer. If I now change the representation to a 3D view, maybe now it can be better realized what happened. Basically, the wind loads have been applied on the selection and it is presented in this layer. So this is what can be achieved with the selection, and also on the 5th tab you can choose between the already stored selections and apply this selection to the representations. Finally, we only have one tab that we didn't talk about, and this is the last tab, on which you can select the CDB to be presented in Wingraf. Previously, I mentioned that it is possible to represent the results or the system values of a different CDB as well. And below this tab you have the opportunity to do this, but first you need to import another database, or I can also say open another database. If I go to the top icon line, I find this icon Replace Database. I will simply select it and choose another CDB to be imported or to be replaced with the current one, and I will hit the Open button. Now I am directed to the dialog box which is called Replace Database. Here Wingraf asks me which database to be replaced, so the old database is going to be the ptc_bridge.cdb, which is fine. This is what I would like to change. Hence, I'm going to click on the OK button. And as you can see, a second CDB appeared below this 5th tab, the 2D Simple Slab CDB, and it is currently presented. Now I also have the opportunity to change between the databases simply by double-click on it. And now the ptc_bridge is presented. If I double-click once more on the 2D Simple Slab CDB and click on the OK to replace the old one, now the 2D Simple Slab database will be presented. With this information we can conclude this video, and I'm going to continue the explanation of Wingraf in the next one. In this video I'm going to show you how to insert graphics into the overall report. First, I would like to clarify the following things. Every time a task is being run in SSD, a corresponding report browser file of the specific task will be created. If you remember, we always clicked with our right mouse button on the calculated task and choose the reports, and we were directed to the report browser of this particular task. For example, at the moment I am presenting the report output, so the report browser file of the definition of the result sets. Please notice that the extension of a report browser file is always a name and then the PLB. The first portion is always the project name underscore, and then every report has its own number. If you look at this number carefully and remember it, when we go back to SSD and open up this task with the text editor, you will also find this number right after the name of the used modules and after the command urs:. If we go back to the Home tab or the Home ribbon bar, we will also find the report browser icon there. If you click on the small arrow below the report browser icon, you can also see and select any of these report browser files, PLB files, for representations. However, it's also possible to receive the overall report by clicking on the All Reports option, and now the overall report will be open. In the bottom right corner you can see that this overall report is quite extensive. Altogether it has 808 pages. If I click on the very first task and choose the collapse all the tasks and their reports will be incorporated in this overall report. On the second tab you can see that this overall report contains a lot of pictures. What if we would like to add additional user-defined pictures to this overall report? Is it possible? If yes, how we can achieve this? Well, the answer is yes. All you need to do is to insert the so-called interactive graphic into the SSD task tree and create the graphics and the layers within it according to your taste. And finally, they will be converted into a PLB file and they can be a part of the overall report. Let me show you now how to do this. First of all, we need to consider at which location we would like to insert our picture into the overall report. Let's suppose that now we would like to add one more picture to the very end of our overall report. So I will right-click on the last task and I will select the Insert Task option from the drop-down list, and if I scroll down, I will find at the post-processing the opportunity to insert an interactive graphics. I will click on the OK button. Of course, now I have the option to rename this task if I want to, and with a double click I will be directed to Wingraf. Now I'm going to generate some new pictures as we learned together already. I'm going to click on the new graphic and I will simply select the beam element, forces and Y bending moment from load case 52, for example. Click on the yes. Then I will just simply click on the insert new graphic, and instead of load case 52, now I will select load case 51. So basically, if we look at the graphics tab, we are going to see I have 1, 2, 3 graphics, and within these 3 graphics we have 3 pictures, and once I'm presenting the structure, then bending moments from 2 different load cases. Please also notice that instead of the GRA graphic file type, now we can see or read GR hash. The GR hash is a temporary type of graphic file in which this information, what we had said, is stored. Now I will simply click on the close button and I will receive 2 warnings. The first of them is whether or not I would like to save the changes in this GR hash file, and I will answer yes, of course. And now I'm going back to SSD or directed back to SSD, and I'm receiving the second question, whether or not I would like to accept the changes, and I will click yes. This second question was triggered because, similarly to every other task, this interactive graphic has also a text input. If you remember, when we right-click on a task, we can have a look at its corresponding text input. This is also the case, of course, with the interactive graphic. As you can see in the background, module Wing is working, and we can read the available commands such as page, control, size, and so on and so forth. We do not need to know these commands since this text input was generated automatically with the help of this interactive graphics. So now I will close back this text input, and all we need to do now to right-click on it and choose the Calculate Interactive Graphics. With the help of this calculation, now a report browser file has been generated. Let me show it to you. If I right-click on the task and choose the reports, then I am directed to the report browser, and as you can see, 3 pictures has been created based upon my input. First the system, then the representation of the bending moment from 2 different load cases. Now I will close back this report browser file, and I will also search for this for these 3 pictures in the overall report. So I will click on the report and choose the All Reports option. Now the overall report will be open, and hopefully at the very end of the report, if I collapse all the chapters, I'm going to find my interactive graphic. Yes, it is there, and I can see and find my 3 pictures, the system and the 2 bending moment diagrams. So this is a very useful and quick way of adding pictures that we would like to emphasize in our overall report. In this video I would like to play a little bit with you together, and I have prepared a simple example for you to undertake to practice the generation of an interactive graphic. The description to this small exercise can be read on the screen now. So your task would be to create another interactive graphic containing reinforcement results of the superstructure. Please show only the superstructure without the pier in the full picture. One page, or we can say graphic, shall be split in a way that only 2 pictures fit on it. On page 1 and 2, the longitudinal reinforcement layers 1 and 2 should be shown, and then 3 and 4 should be presented on the next page. Page 3 should represent the stirrup reinforcement layers 1 and 2. And basically the line representation is suggested for the representation type. And then the location of this interactive graphic should be placed after the beam design task. Okay, I will show you how I would do this, and then you can try to reproduce it on your own. Let's go back to SSD and start it. So now I'm back to SSD. First I'm going to delete the already created interactive graphic, and then I will start with the generation of a new interactive graphic. So I will simply right click on the last task, and then insert a new task option will be selected by me. Then I will choose from the post-processing tasks the interactive graphics and click OK. I will also rename this task by right click on it and choose the rename option and enter necessary amount of reinforcements. Then I will double click on this task and Wingraf will be open on the other screen. So I will drag it into this one. I will go and click on the 4th tab, which is the Layers tab, and here I'm going to first split the page into 2 parts. So I will select and click on the Setup option, and here along the height I will choose the division to be equal with 2. Then I will simply click on the OK button. Of course I need to adjust the view. So I will go to the ZX view. I will use the box option and only present the superstructure. I'm going to turn off the representation of the stations and the axis, so I will go to the edit menu and go to the axis and choose the show axis, the sub menu, and there unselect the central lane of bridge. In this way both of the axis and the placements have been disappeared. Now I would like to get rid of the tendons in this picture, so I will simply select not to show them. Then I'm going to click on the design here, the design values to be presented, and I'm going to select the beam elements, the design, and here the longitudinal reinforcement layer 1 to be presented with the line representation. It is also very important according to the description, and I will click OK. Now I will adjust a little bit the diagram, so I will enhance the size of the text, something like this, and at the same time I'm going to reduce the magnitude of the diagram. Now I will select the first tab, since in the next pictures I only need to change the presented values. So I will simply click on the Insert New Picture button, and now a new picture automatically inserted into the rest of the page, and I will select to be presented the longitudinal reinforcement layer 2. I will keep clicking on the Insert New Picture, because in this way a new graphic will be automatically generated with the same split on it. Now I will just simply select reinforcement layer 3. Then I will keep clicking on the insert new picture and I will select the longitudinal reinforcement layer 4. Still, I'll keep clicking on the insert picture button and now I will choose the stirrup reinforcement layer number 1. Once more I'm clicking on the new picture icon and I will select the stirrup reinforcement layer number 2. And I think basically we are done. But if I go and click on the fourth tab, the layer tab, we can review what we did. And according to the description, we have created 3 A4 papers, 3 graphics. In the A4 papers, we have 2 pictures, and we are representing the necessary reinforcement layer for the longitudinal reinforcement and also for the stirrup layers. So we are really done, and what we need to do is simply close Wingraf, and then we need to save the changes by clicking on the yes. And if we go back to SSD, we also need to accept the changes by clicking on the yes button. And lastly, we need to calculate this interactive graphic by right-clicking on it and choose the calculate necessary amount of reinforcement option. If we want, we can check this in the report by right-click on the task and choose the reports option, and then the report browser will be open and really show the 3 pages with 2 pictures on every page with the correct content. Okay, so this concludes this video. I hope you enjoyed it, and now please try to redo what you saw in this one. In this video, I would like to show you how to adjust the interactive graphics that had been automatically generated in the report of a task. You might remember when we looked at the results of some of these design tasks, the images or graphics contained within these tasks or reports didn't look always the best. So we can adjust it. Let's check, for example, the stress limitation for all beams. Right-click on it and choose the reports. And if we open up the report of this task and go to the graphics tab, you will see that some of the pictures has problems. For example, the diagram is too big or the numbers are too small. Also here, for example, I believe we have some problems with the text is outside the frame or intersecting with another text. So these things should be revised, and this is what we are going to do in this video. Please go back and click on the results tab, because I would like to call your attention to something. If you click on the first chapter, the CSM chapter, and make the text a little bit more readable, then you can also find not just a description of the design task in this report, but also an overview about the results of the beam elements in Wingraf. If we scroll down the page, in the legend we are going to find a very detailed description. These plots are already prepared for interactive changes. Please open Windows Explorer and double-click on the file ptc_bridge_45.gra. Then please immediately store the .gra file under another name to keep your changes. Or another way is to open SSD, insert a task interactive graphic, and from there open the file ptc_bridge_45.gra. So this legend tells us that actually these graphics have been stored in this 45.gra file, and if we revise it somehow and insert into the SSD task tree, then the revised and nice looking graphics will be presented in the final overall report. So this is what we are going to do. First, we just need to turn off the graphics that we do not want to present in the report. Therefore, I'm going to right click on the CSM, collapse everything back, and I will open up once more the first entry and simply turn off the bulbs of Wingraf, because in this way these pictures or graphics will not be presented in the overall report. And now in SSD we are going to regenerate these graphics. So now I'm back to SSD. I will right click on the stress limitation of all beams task, select the insert task from the drop down list, and then scroll down the list and choose from the post-processing group the interactive graphics and double click on it. I will also rename this task. So right click on the task and choose the rename option, and I will rename it to adjusted stress limitation graphics and hit the enter button. Now I will simply double click on this interactive graphic task and Wingraf will be open on the other screen, so I will just drag it to here. And now I simply need to click on the open button. All changes will get lost. Do you want to continue nevertheless? I will say yes. And now I need to choose from the project folder the ptc_bridge_48.gra file and click on the open button. And now, as you can see from the extension of this file, it is a GR hash file, and all the changes that we are going to make will be stored in this file. Okay, now let's try to revise this picture. So I will go to the graphics tab and see what we have here in this file. What I can see, I have 6 graphics, so 6 A4 papers, in which I have different amount of pictures. For example, in the first one I have only 1 picture, in the second A4 paper I have 2 pictures, in the third one I have even 3 pictures, and so on and so forth. So what I'm going to do, I'm going to go through the graphics and the pictures one by one and revise them individually. Okay, let's start with the first one. I will select the layer, and here I'm going to reduce the magnitude of the diagram to have a much smaller one. In this way the text will be able to fit in. Also, I'm going to get rid of the representation of the springs and the couplings. So I will open up the groups and I will deselect the constraints and the springs, and I will hit the OK button. Now I only have the superstructure in the picture. Since I only have 1 picture in the A4 paper, I will change the page setup and choose only 1 picture per height, and then click on the OK button. I think it also would be necessary and reasonable to change the text size. So I will go to the edit menu and go to the text submenu and choose the change properties. Here, by default, the one and only text already highlighted and selected. I just need to add here, yes, please select this. And now I need to change the properties of this text. First, I'm going to enter 0.30 for the height of the text, and then 0 for the angle of the text, and I will hit the enter. Okay, now I am satisfied with the settings of the first A4 paper and the first picture in it. Let's have a look at the second graphic and the picture in it. In this A4 paper, I would change the setup again to have only 1 split on the page. Also, I would get rid of the representation of the springs and the constraints at the groups selection, and then hit the OK button. And maybe in this case we could a little bit increase the magnitude of the diagram with this slider. And that's all. I think the second graphic is also fine now. Let's have a look at the third graphic, because I think this was the most troublesome. Yes, it is. I think what we can do here, or what the best would be, is to change the splitting of this A4 paper from 3 to 2 and create an extra A4 paper. Then we are going to have much more space. So what I'm going to do is actually I will right click on this graphic number 3 and I will choose the new graphic insertion, and by default now I received a new graphic with the exact same content as graphic number 3. Now I will go back to graphic 3 and I will change the split from 3 to 2. I will also add a user-defined scaling factor being equal with 250, and then simply I will take out this adapt and click on the OK button. As you can see, the third picture was automatically moved to graphics 4. This is what I wanted. So now I go back to graphics 3 and adjust these two pictures here. So what we need to do is again get rid of the unwanted groups such as the springs and the constraints and click on the OK button. Then I will revise the scale of the diagram for the first, and I'm going to copy over this property by selecting the second layer and choosing the replace layer properties, and then the magnitude of the diagram was also set in the second layer. I think now the magnitude of the diagram, the texts are also fine, and also the text within the picture. In the second picture we need to get rid of the unwanted groups, so the springs and the constraints once more, and then hit the OK button. And for me, picture number 2 in graphic 3 is also fine. Let's have a look at graphic 4. Now again we need to get rid of the groups and then revise the magnitude of the diagram, then everything will be fine. Then let's have a look at the further graphics, graphic number 5. Then if we look at graphics number 5, this is just a replicate of the original setting of graphic number 3. So I can delete it by right clicking on it and select the delete option. And now graphic 5 will show me the rest of the results. However, on these graphics the picture looks nice and normal or reasonable for me, so I'm not going to change anything here. If we want, we can make a final review by scrolling through our pictures with the help of this button here. If I click on it, as you can see, I'm going backwards in the pictures, and as you can see, for all the pictures, I think we can say that they look reasonable now, so they can be really printed in the overall final report. Now we just need to close this interactive graphic by clicking on the X in the top right corner, and we are going to get the same warnings as usual. Yes, I would like to save the changes, and if we go back to SSD, I'm going to get the second warning, accept the changes, yes, and all we need to do now is to run this task by right clicking on it and choose the calculate adjusted stress limitation graphics. And now if we look at the report, we can have an overview about the revised graphics, A4 papers, and everything looks fine for me. Going back to SSD, I just want to emphasize once more. So basically, the report of the stress limitation of all beams task will be created. However, we turned off the automatically generated graphics within it, so it's not going to be presented in the report. And we inserted a new task in which we have adjusted the stress limitation graphics to be able to represent nice plots in the overall final report. With this information, we can conclude the whole chapter of the explanation of program Wingraf. And in the next chapter, I'm going to explain how the result viewer is working. Before we jump into it, I'm suggesting you to click on the Save button and save our project.